I want to talk about science as a kind of activity that occurs nature-wide. It's called naturalized science. So science is not the human invention. Basically, it happens and it's practiced by all organisms. And I guess the key person here who helped scientists realize things was a big philosopher of science called Karl Popper. Here's a quote from one of his books. I think one of his books was entitled "All Life is Problem Solving," and then he's remembered for this great quote from the amoeba to Einstein: "The growth of knowledge is basically saying no difference." So what I want to do is to perhaps explore this concept of, science being a nature-wide phenomenon practiced by many different organisms. And there is quite a lot of evidence for that in the scientific literature. Today, some people would argue that the science in the modern form was just one local product of the Western Europe and the Enlightenment and the Renaissance, that sort of thinking. But science as a naturalized activity existed in the ancient or human societies, and it's called sometimes native science. And I guess people are becoming more conscious of this because it's mostly because of the problems faced not by physics or chemistry, but practical problems faced by some branches of biology, in particular ecology. So we all know that we live in a period in which, the environment is heavily damaged, and scientists are trying to resolve some ecological problems using all the means available to modern science, but sometimes they can't find a solution. So the last sort of 10 or 20 years, ecologists realized that native people actually do have solutions to some of the problems faced by modern ecology. And this is known as traditional ecological knowledge. So this traditional ecological knowledge is something that's basically practiced by native peoples living at different areas of the world, and this was passed from one generation to another. And actually, they had very detailed knowledge of many natural phenomena that helped them resolve some ecological problems that we face today. And there is a almost widespread practice now that the ecological conferences and experts would often invite the representatives of native people to share the knowledge of this traditional ecological knowledge with them to help basically science resolve ecological problems. And there is a book, this slide you can see the front page of a book called Traditional Ecological Knowledge that was published by the Cambridge University Press, one of the biggest science publishers in the world. I think the book was published 2018. So basically what we call modern science is one thing, and the education system call it proper science, but science in a different form existed actually long before the modern science, millennia before that. And all native societies, through their traditional ecological knowledge, practiced that form of science. In science, there are people who, or in philosophy, people who had more clear views of nature, wider views that incorporate even this traditional ecological knowledge. And an example here is an American philosopher, Charles Sanders Peirce, very famous philosopher. He was actually a scientist by education. He studied chemistry, and he was an excellent logician. And he taught that science basically exists nature-wide. And he's, you can see this title of the book, Evolutionary Love. And he was actually father of the entire science of biosemiotics. I think I discussed biosemiotics in the first week. Certainly a very, very influential philosopher. And you can read a quote by another philosopher, Bertrand Russell, again, one of those influential modern philosophers, who said that Charles Sanders Peirce is basically, he taught the greatest American thinker ever. chemist, logician, biosemioticien, excellent philosopher. So he taught that the roots of science are actually in nature. So science is not a human invention. And this can serve now, to us to search for the natural roots of science in nature. So native people practice science probably by copying nature. And this guy, Karl Popper, that I mentioned him earlier, he actually taught the same. He taught that science is a nature-wide phenomenon. His famous book, Objective Knowledge, An Evolutionary Approach, he looked at the entire evolution to understand the origin of science. And his famous quote here that was not really taken seriously by scientists at the time when he was publishing this book. But now he has been proven right, as you will see later. At the end, I'll show you how one single cell, one amoeba actually, does science. And the name of that amoeba is the blob. I think you probably remember that from the first week. So Karl Popper is a key guy who taught that science has naturalist roots. We can call it naturalized science. And the key principles of that naturalized science is, remember, trial and error. Remember that table from native science. Practitioners of native science themselves identified the principle as trial and error, but we can now apply it to the entire natural world. Bacteria do trial and error. Cells like amoebas do trial and error. Animals, and I'll give you later on examples of how animals do that. So the last thing I want to mention here in this presentation is spiders, but this is not in the context of tool use. This is in a different context, basically forward planning. So you can see quite an interesting picture of this Poer spiders. These are jumping spiders, basically. So they use trial and error in the process of the solution of the confinement problem. For example, they may be kind of environment where they're surrounded by water and they need to get out of that water field, and they can do that. They actually jump. These are jumping spiders. And what they typically do, they synchronize their own behavior that do those trial jumps, one of which is certainly an error, and the other one is sort of less erroneous. So, this trial and error allows them to adjust their own behavior, and eventually they will get out of the water. If they're confined in an area or surrounded by water, they need to find a piece of dry land, and, they solve that using trial and error. And I just want to finish this by just giving a quote of one scientist who was a very clever guy, Richard Feynman, a physicist, and he got the Nobel Prize for physics. And I think his more famous quotes, he was sort of confronting philosophers and sort of playing jokes with them, saying the philosophy of science is as useful to scientists as ornithology is to birds. But he didn't want to be disrespectful to philosophers. He was simply alluding here that the human ornithology is just a human artifact, putting sort of kind of shackles on nature. But we know that the birds basically are emerged through the evolution from some other species, and then the birds may, in the future evolution, produce another species. Everything is changing. There is nothing dogmatic. And I think I'll give you another quote by Feynman, who says that science itself is to some extent dogmatic, because often scientists really take dogmas very seriously. And it's known, I think some of you use that term paradigm shift. It's very difficult to move from one paradigm to another. And, and what Feynman says here is that really scientists have to be brave to challenge their teachers. So this is, I mean, the quote is long, so I'll left it to you to read, but the essence of it, that there is a big danger of belief in the infallibility of the greatest teachers of the preceding generations. So this is a kind of artful look at science, that things change, theories change. You know, theory is not scientific unless it has seeds of its own destruction, replacement by another theory. And that's sort of creativity in the scientific terms.